Discovering electrons. In the 19th century, scientists were experimenting with passing electricity through gases using discharge tubes like this. There was a glass envelope into which was placed a negative cathode at one end, the positive anode at the other end, with around 5,000 volts between them. The invention of efficient pumps allowed the pressure of the gas inside to be reduced to very low levels. Initially there was sparking between the two, but as the pressure was reduced, violet streamers appeared, like this. As the pressure is reduced further, pink regions, sometimes striped like this, appeared at the anode side, with a blue haze like this around the cathode. There were dark regions here, which was known as Crookes dark space, and here, known as the Faraday dark space. As the pressure was reduced further, the pink and blue regions disappeared, the Crookes dark space expanding to fill the gap, and the glass around this end appeared to take on an eerie green glow. Scientists thought that there were rays travelling from the cathode. They were then named cathode rays. A different arrangement of discharge tube here, with a small paddle wheel in the middle. As the cathode rays were turned on, the paddle wheel was seen to turn. This showed that the cathode rays had momentum. This is a more complicated discharge tube. We have a filament here, rather like the filament in a light bulb. This is heated by this low voltage power supply. That causes a cloud of electrons around the outside of the filament. We say the electrons have been boiled off. The filament is also connected to the negative side of a high tension or high voltage supply. The positive side being connected to this metal plate with a small hole in the middle. So this acts as the anode, the filament is acting as the cathode. Electrons boiled off from the filament will find themselves attracted towards the positive anode. A small number will pass straight through and head towards this screen at the other end of the tube. This is coated in a special paint which will glow when the electrons, or cathode rays as they were called at the time, hit it. In a famous experiment, a piece of metal shaped like a Maltese cross was placed between the anode and the screen. It created a shadow on the screen, showing that the cathode rays travel in straight lines. In 1897, J.J. Thomson showed that the rays were deflected by a magnetic field in the same direction as negatively charged particles are. At the moment there is no magnetic field placed across the tube, and the cathode rays are making a small dot in the centre of the screen. When a magnetic field is placed into the screen, the dot is seen to move down. So no magnetic field, the dot is in the centre. When the magnetic field is applied, the dot moves down. He also showed that they are deflected in an electric field, as negative particles are. In this arrangement we have a screen at this point allowing us to see the path of the cathode rays. At this point I've shown a dotted line. We would not be able to see the cathode rays coming across here. There is an electric field in this region with a negatively charged plate above and a positively charged plate below. The cathode rays are bent down like this towards the positive plate and away from the negative plate.